Today we're going to be dividing polynomials using long division. You've done this before whenever you were working with just numbers. Let's take a look at example 1. We have 825 divided by 3. 825 is called our dividend. The 3 is the divisor. Whenever you were in school, they taught you to put the 825 inside the little box. And they said to put your divisor on the outside. And then you had to see how many times that 3 would go into the numbers. So you would look at the 8 first and you say, okay, how many times does 3 go into 8? Well, it goes in twice. 2 times 3 gives you 6. You subtract it, and then you do 8 minus 6 gives you 2. You bring down your next digit, and now you have a 22. Then you had to ask yourself, okay, how many times does 3 go into 22? Well, 7 times, because 7 times 3 gives you 21. So you multiply 7 times 3 to get that 21. You subtract it and you get a 1. Then you bring down your last digit, which is the 5. And you ask yourself, how many times does 3 go into 15? Well, it's a 5. Whenever you divide 825 by 3, you get 275. And this is your answer. I'm going to show you how to take this same process and apply it to dividing polynomials. So let's take a look at example 2. I have x squared plus 3x plus 5 all divided by x plus 1. Now this is going to be very similar to long division whenever you were using just numbers, but now we're doing it with polynomials. So you're going to put your dividend inside that little box. I have x squared plus 3x plus 5. I have my divisor, my x plus 1, on the outside. Now, we can't figure out how many times x plus 1 goes into x squared. But what we can do is we can say, okay, what can I multiply times x plus 1 to get an x squared? So I can say, well, I can multiply by an x. X times x gives me x squared. X times a positive 1 gives me a positive x. So I multiplied this x right here into my divisor, and I was able to get x squared plus x. Well, if you remember, we always had to subtract to be able to get rid of it from our dividend. So what I'm going to do is I'm going to subtract this entire thing. But because there is a binomial, I actually have to subtract both of them. So what I can do is I can put a minus sign on the outside of the parentheses and distribute the minus. Or an easier way, or a shortcut, would be to change all my signs. So this positive x squared becomes a negative x squared, because whenever I subtract something positive, it becomes negative. And then this positive x, I'm going to actually change that so it's a negative x as well. And now I can subtract what I got from my dividend. So x squared minus x squared cancels. If it doesn't cancel, you know you did something wrong. It should always cancel that first term. Then we have 3x minus x. I end up with a 2x. And I'm going to bring down my next term, so plus 5. Then I'm going to ask myself, okay, what can I multiply times x to get a 2x? Well, I can multiply it in a positive 2. And if I were to multiply my 2 times my divisor, I could say 2 times x gives me a positive 2x. 2 times a positive 1 gives me a positive 2. And now I'm going to have to subtract. So I'm going to change both of my signs. I draw my line. My positive 2x becomes a negative 2x. My positive 2 becomes a negative 2. And now I can say 2x minus 2x. Well, that's going to cancel. Remember, if it does not cancel, you did something wrong. And then I have a 5 minus 2, which gives me a 3. Then you ask yourself, what can I multiply times x to get a 3? Well, it's impossible. So this happens to be our remainder. Our quotient, whenever we had x squared plus 3x plus 5 divided by x plus 1, we ended up with x plus 2 and a remainder of 3. Well, we don't write it like this. Sometimes your teachers would have you write it like this. Sometimes they would have you write it over your divisor. The way we're going to write it is we're going to say our answer is x plus 2. And then since it's a positive 3 that was left over, we're going to put plus 3 over our divisor of x plus 1. And this is our answer. Let's take a look at example number 3. Now, example number 3, we have 6x squared minus 19x squared plus 16x minus 4, all divided by 6x squared minus 7x plus 2. If I wanted to use long division, remember, inside that little box, we're going to have our dividend, which is that 6x cubed minus 19x squared plus 16x minus 4. On the outside of my dividend, I'm going to have that 6x squared minus 7x plus 2. And then I'm going to ask myself, okay, what can I multiply times 6x squared to get a 6x cubed? Well, I'm missing an x. So I know I can multiply in an x. I'm going to multiply that x that I got at the top into my divisor. So x times x squared gives me a 6x cubed. X times a negative 7x gives me a negative 7x squared. X times a positive 2 gives me a positive 2x. We're going to subtract 6x cubed minus 7x squared plus 2x from our dividend. So I'm going to change all the signs. This positive 6x cubed becomes a negative 6x cubed. This negative 7x squared is going to become a positive 7x squared. And this positive 2x is going to become a negative 2x. 6x cubed minus 6x cubed cancels. Remember, if they don't cancel, you did something wrong. Negative 19x squared plus 7x squared gives me a negative 12x squared. 16x minus 2x gives me a positive 14x. And then I have my minus 4 that I'm going to bring down. Now I look at this and I say, okay, what can I multiply times 6x squared to get a negative 12x squared? Well, a negative 2. So I have minus 2. My negative 2 times my 6x squared gives me a negative 12x squared. My negative 2 times my negative 7x gives me a positive 14x. My negative 2 times my positive 2 gives me a negative 4. Remember, we're going to subtract that polynomial. So I'm going to switch on my signs. That negative 12x squared becomes a positive 12x squared. That positive 14x becomes a negative 14x. And that negative 4 becomes a positive 4. Now, whenever I look at this, I'm going to see what I get left with. This negative 12x squared plus 12x squared cancel. My positive 14x and my negative 14x cancel. And my negative 4 and my positive 4 cancel. So I have a remainder of 0. Whenever you have a remainder of 0, that means that 6x squared minus 7x plus 2 is actually a factor of 6x cubed minus 19x squared plus 16x minus 4. So it goes in perfectly. It's a factor of it. That means that I could actually multiply 6x squared minus 7x plus 2 with x minus 2, and I could multiply those together and get that 6x cubed minus 19x squared plus 16x minus 4. So my answer would be x minus 2. Let's take a look at example 4. Now, example 4, you're going to notice is a little bit different than examples 2 and 3 that we did, because we're always doing the descending order. We always started off with like the x cubed, then we went to the x squared, then we went to the x, then we went to the constant. Well, on this one, we go from x cubed all the way to the 1, but we're missing the x squared, we're missing the x. So what we have to do is we're going to fix it so it doesn't cause us problems and make us forget our spaces. So what I'm going to do is I'm going to get my dividend and I'm going to put it inside the box like I normally do, but I'm going to add the missing stuff. So I have my x cubed. I don't have any x squareds here, but I might have x squareds whenever I multiply it in. So I'm going to put plus 0x squared. I don't have any x's, but I might end up with some x's that I'm going to have to work with. So I'm going to put plus 0x. Then I would need my constant of the minus 1. Now notice my x cubed minus 1 is still x cubed minus 1, but now it says x cubed plus 0x squared plus 0x minus 1. My divisor goes on the outside, so I end up with my x squared plus my x plus my 1. And now I can go ahead and see what I need to multiply in by. So what can I multiply times my x squared to get an x cubed? Well, that's going to be an x. I'm going to distribute that x to my divisor. So x times x squared gives me an x cubed. X times x gives me a positive x squared. X times 1 gives me a positive x. Now, if we didn't have those placeholders of those 0x squared and the 0x, then we wouldn't have known what to do with those. They would have kind of been a jumbled mess. This just helps us stay organized. So what I'm going to do is I'm going to subtract that polynomial from the bottom. My x cubed becomes a negative x cubed. My x squared becomes a negative x squared. And my positive x becomes a negative x. Now, once I have that, I can go ahead and combine like terms. X cubed minus x cubed cancels. X squared minus x squared gives me a negative x squared. A 0x minus an x gives me a negative x. And then I'm going to bring down that minus 1. So now I have this. Now I need to see, okay, what can I multiply times my x squared to get a negative x squared? Well, a negative 1. So I'm going to put minus 1. I'm going to distribute that negative 1 into my divisor. Negative 1 times x squared gives me a negative x squared. Negative 1 times x gives me a negative x. Negative 1 times 1 gives me a negative 1. Now I'm going to subtract that polynomial from the entire dividend. I'm going to change my signs. That negative x squared becomes a positive x squared. That negative x becomes a positive x. And that negative 1 becomes a positive 1. When I combine like terms, I have negative x squared plus x squared, those cancel. Negative x plus x, those cancel. Negative 1 plus 1, those cancel. So I have a remainder of 0. Remember, when you have a remainder of 0, that means it goes in perfectly. That means x squared plus x plus 1 and that x minus 1 are both perfect factors. We could multiply those together and I could get x cubed minus 1. So my answer would be x minus 1. Thanks for watching as we divided polynomials using long division.